Hello everyone, welcome to today's class and today we will go for discussing the concept of impracticality of testing all data and paths. So here we will see while we will go for testing, it is not possible to go for testing of a particular application by taking all the data that are needed and whatever the paths are there from the starting node to the end node. So all the paths, it is not possible, sometimes it is not possible to go for. So today we will discuss some coverage matrices like statement coverage, branch coverage and path coverage. For most programs, it is impractical to attempt to test the program with all possible inputs, whether it may be the valid inputs or whether it may be the invalid inputs due to a combinatorial explosion. We'll go for one example here. Suppose there is a program with 2 bits integers, 8 bits integers as input. So in this to this program, the total number of inputs will be 2 to the power 8 multiplied by 2 to the power 8. And if only 1 second is required to execute one set of inputs, it may take 18 hours to test all possible combinations of inputs. Here, invalid test cases are not considered, which may also require a substantial amount of time. So, in reality, if I am going to input 2 integers, then it is not possible to go for to test the program by taking all combinations of the input values, because the input domain is too large if you are talking about only the valid inputs. If you consider the invalid inputs also, then the input domain may be very large. So one of the basic questions in testing is, when should we stop adding new test cases to our test set? And when we are going to stop testing? Okay, this is the enough number of test cases with me. With this, I am going to stop my testing. So the coverage matrices are used to address this question. So the coverage matrices such as statement coverage, branch coverage and path coverage is there, which helps us to find out what will be the minimum number of test cases that are required to go for a particular test. So the statement coverage states all statements in the program should be executed at least once, and the branch coverage says all branches in the program should be executed at least once, and the path coverage says all execution paths in the program should be exercised at least once. So the best case would be to execute all paths through the code. So if we define statement coverage, choose a test set T such that by executing program P for each test case in T, each basic statement of P is executed at least once. So whatever the test set that is available with me, I am going to execute my program, and whatever the statements are there in P is the program here. So all the statements should execute at least once. If this is happening, then we can say statement coverage is achieved. Now we will look at an example here. Here it is a small program which is going to take 2 inputs, that is x and y, both are of type integer, and we are going to check here if x is greater than equals to 0, then we are going to say x is positive, otherwise x is negative. And similarly, we are going to check the value of y, whether y is greater than or equals to 0. If yes, then I'm going to print the result y is positive. Otherwise, I'm going to display the message y is negative. So this is a small piece of code. And to test this program, if we'll take a test set T1 with various values of x and y, such as x equals to 12 and y equals to 5. And if we run this program, then yes, x is greater than equals to 0. I'm going to print x is positive. Yes. Then I'm going to check the value of y. Yes, it is also greater than 0. So I'm going to print y is positive. So these statements of the program, they gets executed once you are taking x equals to 12 and y equals to 5. If you are taking x equals to -1 and y equals to 35, so again, I'm going to check x is greater than equals to 0, false. So it is going to display the message x is negative. Then it is going to check the y value, y is greater than equals to 0, yes, so y is positive. So some of the statements, they get executed. And similarly, when I'm taking x equals to 115 and y equals to -13, again, so x is greater than equals to 0, yes, x is positive. And again, I'm going to check the y value, y is greater than equals to 0, false, because the y value equals to -13 here, so y is negative. And similarly, by taking this value, x equals to -91 and y equals to -2, I'm going to check the value of x, it is less than 0, so x is negative, it is going to display. And then I'm going to check the value of y, y equals to -2, so it is less than 0, so my program is going to display y is negative. So if I am going to run my program with this test cases or the test set T1, then I am going to say I am achieving statement coverage, because all the statements of my program is executing at least once, right? But we can minimize this number of test cases, or we are going to take a smaller test cases or a smaller test set by only x equals to 12 and y equals to -5 and x equals to -1 and y equals to 35. Then also, if you run throughout the program, all the statements of this program gets executed at least once, so we achieve statement coverage. That means this is the minimum number of test cases. So instead of going for this 4 test cases, if I'm going to reduce it to 2, like x equals to 12 and y equals to -5 and x equals to -1 and y equals to 35, then also I am going to achieve statement coverage, because all the statements of my program are now executing at least once. What is control flow graph? So the control flow graph is basically a graphical representation of the program. So here a node in the graph that represents a basic block, it is called basically, it represents a basic block. So a basic block is a sequence of statements of my program, always entered at the beginning of the block and exited at the end. So it may be a single statement, or if it is representing a true block or a false block, it may be more than one statements. So they basically represent a node in the graph, and the edges in the control flow graph represent the control flow. So in which direction the flow moves in my program. So if you look at here, I am having a small piece of code. If x is less than or equals to 0, so if the condition is true here, then the statements that are between the opening curly and the closing curly, so this is called the true block. So these two statements are going to be executed, and if the condition fails, then y equals to -5 is going to be executed, and whatever may be the condition, true or false, at the end x equals to x plus y, this statement is going to be executed. See, so if I am going to represent this program with the help of control flow notations, so the condition I am going to put in a single node, I am going to nominate this as B0, and the edge that is coming from this condition, again it is having a true branch and it is having a false branch here. So if the condition is true, then what I am trying to do, I am going to execute my true block here. So two statements are going to be executed. So I am going to put in a single node here representing B1. And if the condition fails, so if the condition fails, so no. So yes means true, no, and means false here. So if this is false here, what is happening? Y equals to -5 gets executed. So this is I am going to put in another node that is represented by B2. And whatever may be the condition, either you move in this way or you move in this way, finally the statement x equals to x plus y gets executed. So which is represented by another node, and this is represented by B3. So this is the control flow graph which is representing the program here that is given, right? Now we'll go for branch coverage. So for branch coverage, what we have to do, first we are going to construct the control flow graph. So whatever the program that is you are interested to test, so corresponding to that program, you just create one control flow graph. And now the definition says like this: select a test set T such that by executing program P for each test case D in T, each edge of P's control flow graph is traversed at least once, right? So each edge, so this is one edge, this is another edge, this is another edge. So these are the edges of the control flow graph. So we have to go for choose the test set in such a way that whatever the edges are there in a program, they should execute at least once, right? So now this is the representation or the control flow graph representation of a particular program. So the program statement or the program segment is not available here. So directly I have taken the control flow graph. So if you look at this control flow graph, what is happening? I am going to check the value of x first. So x is less than 0. If yes, if it is true, then what I am trying to do, I am going to negate the value of x and I am going to store x here. And finally, I am assigning the value of x to a new variable, that is z. This is happening. And if the condition fails here, that means x is greater than 0 or greater than equals to 0, then I am moving in this branch or in this edge, and I am going to assign the value of x to z. So this is the entire program basically. And now I am going to choose a test case here. So if I am going to choose x equals to -1, then what is happening? This statement gets executed. So x is less than 0, yes, true, come in this way, this line gets executed. So negation of x, now x becomes +1, and I'm going to update the value of x here, and then I'm going to assign the updated value of x to the variable z. So with this I am moving in this way. So first this B0 node executes, it is true, I am moving B1, then I am here moving in this way, and I am going to execute B2 node. So whatever the statements are there, all these three statements that are executed with the test case x equals to -1. So I am achieving statement coverage. But question is, with this test case value, whether you are achieving branch coverage or not. No, we are not achieving branch coverage, because whatever the false branch is there here or this edge, I am not able to traverse. So with this test case x equals to -1, though we are achieving statement coverage, we are not able to achieve branch coverage. Now, so what we have to do, we have to go for updating the test case. So I am going to add a new value of x here. So I am updating my test set like x equals to -1 and x equals to 2. So once I am going to give x equals to 2, I am going to check here B0, the condition fails. Now I am moving in this way, and I am going to execute the B2 node, right? So that means all the branches, so ये first branch था, that already we have traversed, and here I moved in this branch also with the value of x equals to 2. So now with this test set, I will say that I achieve both statement coverage as well as branch coverage. Now we will see the concept of path coverage. So the path coverage definition, if you see, it states, select a test set T such that by executing program P for each test case D in T, all paths leading from the initial to the final nodes of P's control flow graph are traversed. So starting from the starting node till the end node, whatever the paths are there, you have to choose the test case in such a way that all the paths should traverse at least once. So if we'll go for the same program again, this program is going to take two inputs, both are integers, x and y. I'm going to check the value of x here. If it is greater than 0, x is positive, otherwise x is negative. I'm going to check the value of y. If it is greater than or equals to 0, y is positive, otherwise y is negative. So the corresponding control flow graph, if you look at here, it will look like this. So this is the condition I'm going to put in a node. If it is true, I'm going to execute this line. I'm going to put in node B1. If it is false, I'm going to print x is negative. So I'm going to put it another node, that is B2. Then what I'm trying to do, I'm going to check the value of y here. So I'm going to put in another node B3. If it is true, then y is positive. I'm going to put another node. And if it is false, I'm going to print y is negative. I am putting in another node. And finally my program ends. So this is the return statement. Here my program ends. Right? So if you look at here, from the starting node, so B0 is my initial node or the start node, and B6 is my end node or the last node or the terminal node, you can say also. So if you look at here, how many number of paths are there from B0 to B6? So if you look here, B0, then B1, then B3, then B4 and B6. This is one path. B0, then B2, then B3, then B5, then B6. This is another path. B0, B1, B3, B5, B6. Another path. B0, B2, B3, B4 and B6. Another path. So total, there are 4 possible paths are there from the initial node B0 to the terminal node or the last node of my graph, that is B6. So the path coverage says you have to choose the test cases in such a way that all possible paths from the initial node to the terminal node should execute at least once. Now we'll see here, suppose we have taken this test set T2 with the different values of x and y, like x equals to 12 and y equals to -5, and another test case like x equals to -1 and y equals to 35. So by taking this value x equals to 12 and y equals to -5, if you will traverse through this graph, then what is happening, you see x is greater than equals to 0. Yes, true, because x equals to 12. So you move in the true side. So move to B1 node. So you are going to print x is positive. Then again I am going to check the y value. So y equals to -5. Move in this way. The condition fails. So move to B5 node and then B6. So the path is like this: B0, B1, then B3, then B5 and B6. So one path traversed. If you take x equals to -1 and y equals to 35, then what is happening? You check the condition, fails, move in this way, execute B2 node, move in this way. Now y equals to greater than equals to 0, you are checking the condition, yes, true, move in this way. So B4 node executes, you are going to print y is positive and then return. Right? So you see, with this 2 test cases, so though we are having 4 possible paths are there from the initial node to the final node, but only we are able to execute or the traverse 2 paths only. One is B0, B1, B3, B5, B6, B0, B2, B3, B4 and B6. So with these 2 test cases, so though we achieve statement coverage as well as branch coverage, but the path coverage is not achieved. So what we have to do? We have to go for updating the test set. So how we are going to update it? We are going to add some new test cases. to update this test suite. So now we are going to add some new test cases like x equals to 11 and y equals to minus 13 and x equals to minus 91 and y equals to minus 2. So with this updated value of the test cases, if you will run this control flow graph, then we can able to traverse all the 4 paths, right? So that means we achieve path coverage. So once path coverage is there, so automatically the statement coverage will be there and also the branch coverage will be there, right? So in this class we discussed, in reality or practically it is not feasible or it is not possible to go for testing with all the data, whether it is a valid data or invalid data. And similarly all possible paths, because in some control flow graphs if you see it is having a loop. So loop means if the loop executes 100 times or the loop executes 1000 times or the loop executes 10,000 times, then whatever the possible paths are there, all the paths are not possible to test. So that is the reason why the coverage matrices are going to help us to design the test cases or to reduce the number of test cases so that efficiently we can go for test it. So with this we are stopping today. Thank you.